Welcome to the 10-minute whirlwind tour of Project Macoma. It's nice to follow Adam because we're also working with an aqueous alkalinity. So specifically what Ebb is doing is electrochemical. We take in seawater or brine, we process, sorry, I'm short. We process that in an electrochemical setup that splits salt into acid and base. The acid is removed and the base is mixed into seawater. When you do that, the local impacts are elevated pH, elevated alkalinity, decreased PCO2, and you have some area where you can measure it, and so on. So we've actually done 2 different field trials in Washington, the Pacific Northwest. Our first real field trial was a collaboration called EZO-A. This is a private-public partnership between Ebb, University of Washington, Pacific Northwest National Lab, and NOAA PMEL. And we did biological trials, high-resolution modeling, a variety of different mesocosm experiments, and then we did 2 small alkalinity releases using the on-site wastewater treatment plant into Squim Bay. If you haven't seen those papers, please feel free to reach out. Effectively, what's happening in this situation is we are working under an existing permit that limited us to a pH 9 release, and that really chokes what you can see in the field, and it limits the amount of research that we were able to do. So when Ebb was ready to scale and to test our technology, we looked for a site where we could work without that initial influence of that pH 9 limitation, because that's something that we need to understand what it looks like, what are the boundaries of safe operation. So we landed about 30 miles west in Port Angeles. This is an overview of what the harbor looks like. It's a natural deep water harbor on the Salish Sea. Long history of human habitation, heavy industry, a lot of pollution, a lot going on in the site. So the little red box on the left is where we're operating. So we're leasing land from the Port of Port Angeles log yard with a pre-existing pier that allows us to walk across most of our site, which is really convenient for doing this research. So this is a zoom in on a drone shot from the site. We have both on-land and offshore assets to what's happening at Project Macoma. So, okay. So in order to produce alkalinity, we're taking in seawater onto this barge, we pump it to land, we desalinate, and that concentrates into a brine. That brine is processed using electrochemistry. We produce acid and base. For this project, acid is neutralized on site with brucite, and then the base is sent to a product mixing tank. And then we release that mixed alkalinity seawater solution at some predetermined pH back out an outfall diffuser that's supported from the barge. You can enjoy a photo of the research barge Isoman. I want to stress that this is a research pilot. This is not how we would intend to scale this technology. We burn a lot of energy pumping seawater around. We built a desalination facility. It's not efficient for doing CDR, but it is efficient for testing permitting pathways and for actually being able to see in water signals over long periods of time. So this is the first project that is permitted for the purpose of MCDR under the U.S. Clean Water Act. There's a lot of permits associated with this. The most important one for this audience is the NPDES, or the NPDES. It's a National Pollutant Discharge Elimination System permit. And what it does is it sets up a mixing zone. That mixing zone is about 207 feet across. That's the big white circle. And by the edge of that mixing zone, we have to be back to excellent water quality. So any changes in pH and PCO2 have to be diluted. Okay. So we got this permit in October 2024. We constructed the site through 2025 and then began alkalinity releases this past August. But before we did any alkalinity releases, there was a lot of environmental characterization, risk characterization that went into this project. So some of that was permit mandated, some of it was scientific, a lot of it was voluntary, and all of it was expensive. This includes surveys, benthic habitats. Is there eelgrass in the area? What's actually present? It's very polluted sediment. What does that mean for environmental characterization is something we should think about. We did more than a year of water quality and carbonate chemistry monitoring before we ever released alkalinity. We deployed mussels throughout this site. We did fish studies with a local tribe, and so on. We also started doing modeling really early on. So we do a lot of near-field modeling. This uses tools like Visual Plumes, Plumes 2.0, OLI Studios, live ocean ROMs through University of Washington, Oceananigans, and so on. We did do a rhodamine dye test. You can maybe just see the plume kind of going to the east in this figure. And all of that was to characterize the near-field models and to validate them before we released electrochemically generated alkalinity. So for about 6 months, we operated in a few different modes. The first mode are routine operations. This is daily continuous alkalinity release, where we have a pH limit of 9.8. This is already way higher than a lot of us are familiar with for wastewater. And what this plot is showing on the left is dilution models. So what we would expect for where a plume is going and how pH would respond in the near field. And on the right is 2 representative days of alkalinity releases. So the vertical yellow bars are when we're releasing alkalinity, and we're seeing a time series of pH on the top and PCO2 on the bottom. You may see a very small shift in pH at the beginning of one of those alkalinity plumes, well within natural variability for this harbor, very short term. That's pretty much what we saw for 6 months of routine operations. Very hard to detect pH shifts because we're diluting so rapidly. No change in PCO2. We have another mode of operations that we started doing in January and February. This is scientific operations. This raises our pH limit to 12 during certain conditions, typically ebb tide. And in this case, we expect, again, really rapid dilution because of the way the project is engineered. And we did this to test a couple of things. How easily can we distribute alkalinity? How well can we control pH? And what happens with brucite precipitation? It is possible to release high pH alkalinity without forming brucite. Depends on the contact time, depends on the residence time. Come find me if you're interested in that. There's a lot that was done at this field site. Some quick highlights on the technology. We spent a lot of time working with desalination because this is a pilot that should move into a commercial integration next. So there's co-benefits to producing fresh water. We did a lot of membrane technology validation. We are not producing our own membranes. Other MCDR groups are doing that. We're working with off-the-shelf components that are typically used in desalination. We did do a very small amount of net carbon removal delivery under a pre-purchase to Stripe. Okay, we did not have a joint learning opportunity at this site, but we still did do a lot of work to enable scientific research, so I'm gonna give just a couple of highlights of that work. First, we worked very closely with PNNL on precipitation dynamics in the field and in the lab. We also had some low-cost efforts to try and understand, can we see CO2 invasion following alkalinity releases? This is Harriet Robinson from PNNL and Monash University. She spent several months chasing a plume, which is very hard to find, and was able to detect some carbon uptake. We did a lot of different biological testing. Some of this was with local tribes, some with local universities, standard ecotox, novel ecotox. So if you're interested in fish, mussels, any of these different topics, feel free to reach out. There is a salmon study kicking off next week as well. John is around somewhere. We invited researchers into this site in the dead of winter in January of this year. They were doing microbial sampling. This is from 8 p.m. in January in Port Angeles, which is not pleasant to operate in. Keep an eye out for papers from all these studies. And then we did a lot of different sensor tests. So Ellen is here. Feel free to talk with her about her TA sensor. There's a lot of different commercial sensors that we use throughout this process. Some of them aren't familiar to the oceanographic community. Some of them could be enabled to use in the ocean. So there's a lot of different cross-learnings we can work through. Okay, so 6 months of operations. This is a short-term pilot, and we did just wrap this project. So there's 2 reasons for that. One is we leased land for this pilot back in 2024 under a different administration when we knew that there was construction that had to happen on that site this summer. We have a modular site that can be moved, and we intended to come back to that site to use our full 2-year permit. It's not gonna happen. We learned enough from this pilot to be able to move into commercial integration with desalination, and in today's constraints, that is where we have to go. So EB has a pilot project in the works with Saudi Water Authority. If you're coming to the sectoral integrations workshop tomorrow, we'll talk about that more. We are looking for opportunities to continue research at this site as well as at PNNL Swim. And I'll take some water and I will pause there early.